An electric field, like a magnetic and gravitational field, is not visible to the human eye. Some animals, like sharks, have an ability to detect bioelectric fields, but humans have to rely on other methods. In 1600, a British physician named William Gilbert invented a device that was able to detect the presence of an electric field. This device was called an electroscope. In 1787, the gold leaf electroscope was invented by two British scientists. At the bottom of the electroscope were two paper-thin gold foils. The gold foils diverged in the presence of a charge. In the same way, your hair becomes frizzy when you pull a wool sweater over your head. So why do the leaves spread out or diverge when they become charged? The leaves diverge when the normally neutral leaves become positively or negatively charged. They diverge because like charges repel. If no charge is present, the leaves point straight down. If electrons are removed from a neutral electroscope, the whole electroscope becomes positive and the leaves diverge. If electrons are added to a neutral electroscope, the whole electroscope becomes negative, and once again, the leaves diverge. We can charge an electroscope with a rubber rod that has become negatively charged by rubbing it with wool or fur. The rubber rod becomes negative by gaining electrons from the wool or the fur. When the wool loses electrons to the rubber rod, it becomes positive. The number of electrons lost by the wool equals the number of electrons gained by the rod. In this presentation, you learned that an electroscope is a simple device used to detect the presence of a charge. When the electroscope becomes charged, the leaves on the bottom diverge. Objects can become charged by friction. A rubber rod gains electrons when rubbed with wool or fur. The rod becomes charged negatively, and the wool becomes positive when it loses electrons. And this is the end of my presentation.